power. The power of a device is the work it does per second, the rate at which it does work. This is the same as the rate at which it transfers energy from one form to another. Power can be calculated by using this equation. Power is work done over time taken, or energy transferred over time taken. Power is in watts, work is in joules, time taken is in seconds. Let's think a little more about the meaning of power. The engine transfers energy to a car. The power P of the engine is the rate at which it does work. The more powerful a car is, the faster it can accelerate, the more rapidly it does work and gain speed. Pay attention to these two cars. They will travel the same distance. Which one will arrive first? Think for a while. The distance is the same. Suppose the masses of these cars are also the same. So the energy spent by these two cars should be the same. The engine power of the first car is greater than the engine power of the second car. We know this because the first car spent the same energy as the second car, but the first car spent that energy faster than the second car. Let's see how it works. Example, a weightlifter lifts a mass of 140 kilograms, a height of 1.2 meters, in 0.6 seconds. Calculate the power developed by the weightlifter. Work done is the gravitational potential energy transferred. The power is 22,800 watts. Another example. A particular car engine provides a force of 900 newtons when the car is moving at its top speed of 40 meters per second. Calculate how much work is done by the car's engine in 1 second. We know that speed is distance over time. Speed is 40 meters per 1 second. So in 1 second, the distance traveled by the car is 40 meters. Work is force times distance. Work is 36,000 joules. State the output power of the engine. Power is work done over time taken. Substitute the values. We get the power. Another example. A boy whose weight is 600 newtons runs up a flight of stairs 10 meters height in 12 seconds. What is his average power? Work done is the gravitational potential energy transferred. Substitute the values. This is the power. Efficiency of energy transfers. Every time we use a device to transfer energy, some energy has disappeared. The lost energy is often converted into no useful energy, as heat and sound energy. The efficiency of a device is the percentage of the energy supplied to it that is usually transferred, and to calculate efficiency, we use the equation. Useful energy output over energy input. Let's see how it works. Figure below shows a dam which stores water. The outlet of the dam is 20 meters below the surface of the water in the reservoir. Water leaving the dam is moving at 16 meters per second. Calculate the percentage of the gravitational potential energy that is lost when converted into kinetic energy. Water stored behind the dam has gravitational potential energy. We will picture 1 kilogram of water starting at the surface of the lake and flowing downwards and out at the foot. Then, gravitational potential energy is 200 joules. The fast flowing water leaving the foot of the dam has kinetic energy. The efficiency is 64%. So the loss of energy is 36%. If engineers wanted to use this moving water to generate electricity, they would have already lost more than a third of the energy which it stores when it is behind the dam.